Good afternoon, everybody. Welcome to another exciting afternoon of organic chemistry with your host, Dr. White. All right, first thing I'd like to talk about is labs. Some of you haven't been handing in your labs. How do I know that? This morning I caught up with all the labs that people have handed in. It's now in D2L, your lab scores. Remember, maximum page. I'll get to your question in a second, because all questions are good questions. But anyways, if you haven't handed in your labs, hand them in, because I haven't normally been able to nudge you like I would if we were in lab and ECC, and I haven't sent out emails, and I'm learning about online differences right now as we teach this semester. I'm going to cut slack on the penalties for late labs for the next couple of weeks. Then I'm going to get on everybody's case. All right, hand in your labs when you can. All right, my audio is on. Paige, you have a question?
I just wanted to clarify what you said at the beginning. So you said that the university is not, or the ECC is not allowing you to give us.
Let's talk in private about that. There are certain things that we were asked, this is the way you do it, and now I'm realizing that's wrong and I'm changing it.
So we're not to turn in the practice problems is what you're saying? No. Okay.
But those of you have, because that's a lot of work and you did it, and also I'll help you grade. Don't tell anybody that, but yeah, you can. I'll remember that come the end of the semester. Trust me, I have a very good memory. I have to, I'm an organic chemist. In case you're wondering, this semester, a number of years ago, student did a count, and told me, I've never counted it, that I teach about 52, if I remember correctly, or 53 general reactions, like a double bond hydrogen, you hydrogenate it. I personally know about 450 general reactions like that. So I'm only teaching a small amount of organic chemistry, but it's still a lot for you to absorb, which you're doing that. All right, any other questions before I get to work? All right, today I'll continue on with carboxylic acids. Remember, and I'll put out by Saturday, email and an announcement about test number 2, which has been postponed from today to next Wednesday. I'll also put down the point breakdown, and I will put how many pages. Historically, it's 9 pages. I don't remember how many problems. If you've done the practice problems, you should be able to knock it out in about 35, 40 minutes. Take about an hour or so. You're at home. I'm not going to be watching the clock, but you shouldn't be looking at your notes. That I will ask you not to do. And if you do the practice problems, test 2, I can tell you right now, will be a little different than test number 1. How so? Well, the basics, I'm not going to ask you how many carbons are in the longest chain or things like that. I will do nomenclature, 2 types of nomenclature problems. One is, here is the structure, what's the IUPAC name? Isn't it amazing, you know, that IUPAC means the official name, even though I'll never ask on a test. I think it's cool to say International Union Pure Applied Chemistry, IUPAC, in Geneva, but that's one nomenclature. The other nomenclature is, here's the name, both IUPAC and common name, because I've been teaching you common names. That will be worth historically about 35 points. A lot less than test number 1, because you've learned the basics of what's the carbons 1 through 10 and all that. I'm not going to ask you that. Also, the other thing, about 65 points, give or take a few, will be reactions, because I'm spending more time on that. Give the organic product or products. There'll be 3 or 4 questions. Give the starting materials, which I call synthesis problems, which we've done. Boy, this test talking is thirsty work. And then there'll be about 5 to 10 general knowledge points, and those will be on the chapters. The material on test 2 will only be on the material on test 2, which I'll put in an announcement, but just to remind you, it will be alcohol. Hold on. Most people are visual. Can everybody see my whiteboard with test number 2? Can you see it? Thank you. All right. There'll be alcohols. We did that chapter. Thiols. I got them backwards. And I'll just write the names. Ethers. Epoxides, which is really just ethylene oxide. And ketones, my favorite. And aldehydes. I don't know what chapters those correspond to the book, but these are, and we've already gone through all the practice problems. One thing I will remind you, how many, when you use gas, natural gas to cook, thought about that tragedy in Texas where they added T-butylthiol to gas now, natural gas, so you can smell if there's a leak, because methane, natural gas, has no odor to it. Hopefully you thought about that. You should. Okay. And these are the functional groups that will be on test number 2. And like I said, there'll be 3 types of questions. 1, general knowledge. The other, nomenclature. And the third one, reactions. And I'll put out an announcement. And generally, this is about 5 to 10% of the points, or 5 or 10 points. This is about 35. This is about 60 to 65. And depending how I do it, it will add up to 105. So there'll be 5 bonus points. And I'll put out an announcement with all this on in a nicer way. All right, any questions about test number 2? And it'll be the same way, PDF file. You'll get the password after class. You'll have until next day to upload it as a PDF file, your answers. All right. With that, let's get to work. All right. Everybody see on their screen? Oh, wait, let me check. Yep. Everybody see carboxylic acids with sodium bicarbonate? Thank you. All right. We did this yesterday. Remember, on this one, I would ask, give all the products. And let me have you do one. And it's your turn. But since you might not have learned this, I'm going to help you out. All right, your turn. What would be all, this is unusual for Dr. White, but all the products for the following reaction? And if you finish early, please be patient. Excuse me, I try and give everybody time to finish. Dr. White tries to be nice to all, so actually more than tries. I am always nice to all my students, as I try to. All right, I think everybody's done. Let's do it. And we look over here and we say, what's different? Ooh, a carboxylic acid, carbonyl, double bonded, carbon double bonded to oxygen with a hydroxy group that has same carbons here, carboxylic acid, sodium bicarbonate, baking powder. And this is my R group. What do we get? This carboxylate anion, what's R? These three carbons. Remember, you don't break carbon-carbon single bonds. And it's a carboxylate anion. And the other products are CO2 given off as a gas and water. And I hope you all remember the story I gave about the little rocket ship and how my father taught me the candy to take candy, and I threw it out, and all my friends did. Put in this little, looks like a test tube, some vinegar and baking powder, and then put the cap on, shake it and hold it, and it goes boom, flies off. Was that so cool? I can still remember I was about 6, and my friends all thought my father and I was cool. We didn't use the term cool back then, but really it was cool. And hopefully when next time you're cooking and you're making spaghetti sauce, try the 2 things my father taught me. One, just put a little pinch of cinnamon in there, gives it that special high-end Italian restaurant taste. And don't forget to put a small amount of sodium bicarbonate, because that neutralizes the acid, the carboxylic acid from citric acid from the tomatoes, and makes it much smoother. All right. All right, I got everybody's questions. If not, you can either ask now or see me after class. I think I did. All right, let's move on because we've already done this. I've done this slide, talked about sodium benzoate is a preservative, calcium propionate is preservative. One thing I haven't talked about, which won't be on test number, by the way, carboxylic acids and derivatives is test number 3. And this is an area I worked in the chemical industry. When R is very long, or R plus the carbonyl is very long, anywhere from 12 to 18 carbons, atoms, this carboxylate anion has a special name, and we call that soap. And I'll talk later in the semester, I'll have a whole chapter or area on fats and oils, and we'll talk about soap. And I'll teach you the secret, how soap works. By the way, next time you wash your hands, your hair, what I have left of it, or your clothes, same thing with detergents, that's organic chemistry, which is why I always laugh when people say they hate organic chemistry. What they really should say is they hate what whoever taught them organic chemistry, because if it's done right, it's fun. All right, how do you make carboxylic acids? And one of the things my software does, and sometimes it's a C there. If you take a primary alcohol and oxidize it, that's what this means, you can go to a carboxylic acid. Now, you might say, but Dr. White, you just, for test number 2, you taught us this thing. Well, you'll see today why this is true and this is true. But right now, for test number 3, and part of the reason it goes all the way is the reaction conditions. This you do very cold temperature, this you heat up, and it goes all the way, and you'll see why in a little while. But anyways, if you take a primary alcohol, oxidize it, you will get a carboxylic acid. And I've done these reactions for my PhD thesis and other places too. And if we look at the following reaction, give the organic product or product, don't forget you're learning how to use these for building blocks or other than use in your molecules in your daily life. When we look at this and we say, what's different? Oh, it's an alcohol, but it's a primary alcohol. And whenever you're doing an oxidation, O in a bracket, and I'm not asking you to learn all the different oxidizing agents like potassium permanganate, sodium dichromate, potassium dichromate, and others. If you're a chem major like I, or a chemist, you should know those, but you're not planning on that. And what happens is you get a carboxylic acid. Important thing, you don't lose any carbons. So the carbon with the hydroxyl group on it will become the carbonyl carbon of the carboxylic acid. This is my R group. Therefore, I have my 2 carbons attached to this carbon, which will become my carboxylic acid. I know there are 4 bonds to carbon, and that's the product you get. Your turn. What's the organic product or products for the following reaction? Have fun. And when you're done, don't forget to smile or give me a thumbs up. I see some of you. All right, looks like everybody's done. Let's do this. How do you do this? You look at what you're reacting and what's different. What's not a carbon-carbon single bond or in these chapters, what's not carbon or hydrogen? Oh, hydrox group on a carbon, and it's an alcohol, but this is a primary alcohol. Why is that important? Because we're doing an oxidation. And what you get is a carboxylic acid. And I'll call this my R group, carbon and hydrogens. And notice I have 1, 2, 3, 4 across. You don't break carbon, carbon, single bonds. And then I have my 2 methyl groups. The carbon with the hydroxyl group becomes this carbon, the carbonyl carbon. Notice carboxylic acids have carbonyl carbon, just like ketones and aldehyde, carbonyl carbon, double bond to oxygen. And that's what you get. Now, you don't have to put the dot in there or anything like that. Oh, this is fun. Let's do another one. Give the organic product or products for the following reaction. Have fun. All right, looks like everybody's done. Let's take a look at this. What do we have that's different here? Oxygen with a hydrogen and a carbon. It's an alcohol, but we're doing an oxidation, so it's a primary alcohol. And when you oxidize it, you get a carboxylic acid. What's my R group? Methyl. And that's the product you get. Now, can anybody see the special significance and importance of this reaction? Everybody give up? Time's up. Well, this reaction is a reaction that's hated by wine lovers. But first, I'll do something other than that, and I'll tell you what that means in a second. If you were trapped on a desert island and you wanted to make some oil vinaigrette dressing, which is this vegetable oil and some seasonings and vinegar, and you had no vinegar, but you had a lot of alcohol, ethanol, you could oxidize it and make acetic acid. And this is acetic acid, which nobody calls 2-ethanoic acid. And 4% of this plus water is vinegar. And you could make your salad dressing on your desert island, assuming you had a lot of ethanol, say like vodka, the good stuff. Now, the other reason about this importance of this reaction is wine lovers. How many of you have ever tasted a bottle of wine that's gone bad? Any of you? And what does it smell or taste like? Vinegar. It's gone bad. Dr. White likes German wines. All French wines taste bad to me, but I like good German wines. Now, what happens? Let's find out. What's wine? Well, the important thing in wine is ethanol. And a very slow oxidizing agent is oxygen. That's how oxidation got its name, because oxygen will do this, but it's very slow, which means it takes a long time. And this is an oxidizing agent. And as you saw up here, it makes acetic acid, and that's why wine that goes bad tastes like vinegar. And if they bottle the wine wrong and they got too much oxygen in the top of the bottle, with time, it will do this. It oxidizes the ethanol in the wine to the vinegar. Do I have time? Oh, I do. Now, in my fraternity, I went to IIT. One of my fraternity brothers, and this was unusual back then, it's a long time ago, was a IT major, information science, technology or computer major. And he was quite good at programming. And years later, I don't know how he got into it, but he became a programmer for some of the big banks in the United States. Then he went off on his own and was programming and writing programs for the banks in the Bahamas. If you don't know, that's where people hide their money. He was making a lot of money doing that, not hiding his money, but writing programs. Eventually, they made him an offer he couldn't refuse, and he moved down to the Bahamas. But he lived in the Chicagoland area, and he was a wine connoisseur. And because I was doing good in my other fraternity, but this guy was doing real good, he'd go out and buy $200, $300 bottles of wine. He had a condo, and he had a whole wall of wine bottles. Well, every once in a while, he ran out of room in his wall of wine bottles storage. And he'd invite us all over and say, we got to get rid of some of the bottles of wine because I want to buy more stuff. And we would have a nice wine tasting party. We'd bring food, he'd supply the wine. And every once in a while, he'd uncork a bottle, we'd taste it, and it went bad. He'd get upset. I paid a couple $100 for that, and it's bad. And I'd tell him, well, keep the oxygen out of there. And he'd give me a dirty look. But true story about wine tasting. And I guess back then I should have gone to computers. Nah, I like chemistry. Oh, let's do one more of these. These are fun. And let's do a synthesis one. What would be the starting material that you oxidize to make this compound? I'll let you do that one. By the way, this is a synthesis problem, and these are the most fun part of organic chemistry, but I'm biased because I'm a synthetic organic chemist. When I worked in industry, I was always challenged, how can you make this product? And the challenge also included an existing plant equipment for this price, which made it even more a challenge and exciting. And when you're done, give me a thumbs up if your video is on or isn't. Anybody need more time? All right, let's do this. Now, what do we have here? What's different? Carbonyl, hydroxy group, the same carbon, carbons here, carboxylic acid. We're oxidizing it. And what do you oxidize? Now, this for this problem, primary alcohol. The carbon of the carbonyl carbon is the carbon with the hydroxyl group of the primary alcohol. So this is my R group. Since you don't lose or break carbon-carbon single bonds, I have 1, 2, 3, 4, 5 across. And then over here, I have a methyl group on this carbon. The carbon with the carbonyl carbon becomes this carbon with an alcohol, and everything else came along for the ride. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, plus one more is 6. That's how you do it. Now, something I haven't been doing enough of, or usually in a classroom I do it more, but I like to have you all take a second or 2 or 3 to think about, say last July, if I had put that on a board in front of you, or now, and said, look at the primary alcohol, look at the carbonyl carbon, look at the letters on the board, would you even know what I'm talking about? Think about how much you've learned, and you should be proud of yourself. This is organic chemistry. How many of you have heard it's real hard, it's tough, it's painful? I'm sure some of you have, and you're doing it. You should feel good about that. You know, give yourself a pat on the back when you have a chance. Now, another way of making carboxylic acids is if you take an aldehyde and oxidize it, you'll get a carboxylic acid. And this is why I said if you take a primary alcohol, you can oxidize it all the way to carboxylic acid, because you learned for test 2, if you oxidize this, you'll go here. Turns out in real life, which I'm not teaching in this class, this has to be mild. This is strong, and usually that's temperature. This is low temperature to stop at the aldehyde, and high temperature to go all the way on to the carboxylic acid. And this is why. But let's look at this reaction, because I've done this where I've taken aldehydes and oxidized them because I wanted to make the carboxylic acid. And if I were to ask, give the organic product or products for the following reaction, the question is, what do you do? Well, you look at this reactant or starting material and say, what's different? Carbonyl, remember, look for what's not carbon, what's not hydrogen, oxygen, double bond with a hydrogen, and carbons here. It's an aldehyde, and we're oxidizing it. And this becomes an OH, and you make a carboxylic acid. So you break carbon-carbon single bonds? No. So I have 1, 2, 3, 4 across. You could also think of this as being your R group. And now I will get 1, 2, 3, 4 across. This carbon right here, still double bond oxygen, and the change is this hydrogen becomes a hydroxyl group. And it's your turn. What would be the organic product or product for the following reaction? Quick commercial from Dr. White, or actually public service announcement. Two of them. One, don't forget to hand in your labs that are due today. And if you have any past labs, hand them in. If you have trouble with the labs, always feel free to come to my office hours. I'll have one tonight. And the other thing is, this is more a real public service announcement. I don't know if I mentioned it Monday, but I'll mention it now. We have an upcoming election in a few weeks. So what is it, 19 days away, I think now? And brave men and women have died so we can vote. I have yet to miss in my life a general election. One time I had to go out of town real quick and I missed a local primary election, not a state or federal, but a local one for my township. But other than that, since I've been voting, I have never, ever missed an election. I think, I don't know what the law is, how many days in advance you can register if you're not registered. If you are registered, vote. This is probably the most important election of my life and maybe yours. I hope not, but I think it could be. All right, let's get back to organic chemistry. And the question is, give the organic product or product for the following. And if we look here, we say, oh, look, what's different? Oxygen, look for what's not carbon or hydrogen, double bond to carbon with the hydrogen, and we have carbons on there. We have an aldehyde. I can call this my R group. And when you oxidize an aldehyde, what do you get? A carboxylic acid. And therefore, the carbon with the hydrogen, carbonyl carbon with the hydrogen, becomes a carbonyl carbon with the hydroxyl group. Do you break carbon-carbon single bonds? No. So I have 1, 2, 3 across. This carbon has 2 methyl groups. Think about it. 6 months ago, if I said methyl group, you wouldn't even know what I was talking about. See how much you've learned? And this becomes a carboxylic acid. I know there are 4 bonds to carbon. And I can do that, and that's my answer. Oh, let's do another one. These are fun. And the question is, what would you have to react with an oxidizing agent to make the following compound? Your turn. Have fun. Anybody need more time? Going once, going twice? Nobody's screaming, so let's do it. How do you determine what's the starting material for this reaction? Remember, the starting material or materials are what you start with. Well, you look at the product and you say, what's different? Oh, oxygen's here and here. This is a carboxylic acid. And we're oxidizing it. That's what that means. And what do you oxidize? Now, this one, there's two possible answers, but since we're doing aldehyde, and this is one I would never put on a test or a final, because you could put either an alcohol, primary alcohol, or aldehyde. Both would be right, but I'm talking about aldehydes, so let's do that. If we notice, this would be my R group. Remember, you don't break carbon-carbon single bonds, so if I end up with 4 carbons, I better start with 4 carbons. That's always a good check when you're doing reactions, because the only reaction I'm teaching you this semester where you break a carbon-carbon single bond is combustion. We did that in chapter 1. No other chapters do you break carbon-carbon single bonds. It's quite unusual in organic chemistry. And here, since I was talking about an aldehyde, we have my aldehyde. And that's the starting material you have. And that's how you do oxidations of aldehydes. Like I said, I'm going to apologize because I'm going to bring back a really fun memory from my past to share with you. Don't get scared if this scares you. That's pretty a double negative. Don't get scared if this scares you. Here's a molecule, and this is called a bicyclic 2,2,2-octanone ring that Dr. White used, and I oxidized it. To make this carboxylic acid that I needed for my research. And like I said, this is a good reaction. I've done it. Oh, that brought back nice warm memories. That was an exciting time of my life in graduate school. All right, let's look at one more way of making a carboxylic acid. And let me put in here the C, because my software doesn't like to. And here, actually, that should have water. Uh-oh, the slide got hit by the dreaded water virus. But anyways, this is a really cool reaction. And what is it? You take a Gringard, react it with carbon dioxide, first step, second step, acid and water, and you get a carboxylic acid that's 1 carbon longer than the R group you started with. And this is one of those special reactions when you can make a carbon-carbon single bond. Now, I'm going to show you something that I normally don't do. Let's look at the reaction of this with CO2 first. Now, let me also write CO2 this way. If you look at it, this part looks like a carbonyl. And we know the Gringard will attack a carbonyl. It does, and it opens it up to this. This will never be on a test, but it might help you understand what's going on. And you form this. This is the conjugate base of a carboxylic acid, and acid and water, H plus and water, will do an acid base and turn this base into this acid. And that's how this reaction goes. And why do I say it's a really cool reaction? Because one way of doing it is have your Grignard in solution in a reaction flask, and you add dry ice. Dry ice is carbon dioxide. Ah. And that's one way of doing it. And I've done that. You take dry ice, break it up into little pieces, put it in your Grignard, wait a while. It's a pretty quick reaction, and add acid water, and there you go. I'm going to go a couple more minutes before we take our break, and you'll get out early today because it's a lab day. If we were at ECC, I'd lecture like now, and then we take a break, and you do your lab, where I talk 20 minutes, and you go in the lab. All right, let's take a look at this. And the question is, what's the organic product or product? By the way, this reaction with Grignards, I'll never put a synthesis on the test or the final. And we look at it and say, what's different? Ooh, what's not carbon? What's not hydrogen? Magnesium and bromine on a carbon? That's a Grignard reagent. Remember, X can be chlorine, bromine, or iodine, never fluorine. And we're reacting with carbon dioxide. Ooh, second step, that means after this reacts, then you add the second step material. And you get a carboxylic acid that's one carbon longer than the Grignard you started with. And notice this is my R group, 3 carbons. I'll add my 4th carbon, my carboxylic acid. And this is the product I get. Notice I started with 3 carbons here, and I end up with 4 carbons here. You've made a carbon-carbon single bond, and this is a really cool reaction. Yes, you're using dry ice. It's cool. All right. Your turn. Give the organic product or products for the following reaction. And this reaction was discovered also, I believe, by Victor Grignard, which is amazing work that man did. One of my heroes of organic chemistry. Quick public service announcement. Next Monday, I'll do my world famous review for the next test. And students say it helps them. So don't forget to either show up for Zoom meeting or watch the video. All right, anybody need more time? Let's do it. What do we have that's different? What's not carbon, what's not hydrogen? Ooh, magnesium and a chlorine on carbons. That's the Grignard. Remember, X can be chlorine, bromine, or iodine. We're reacting with CO2, carbon dioxide. Second step, acid and water. And what do you get? A carboxylic acid that's one carbon longer than the R group you started with, and you've made a carbon-carbon single bond. What's our R group? Isopropyl. The carbon with the magnesium halide will be the carbon that's attached to the carbonyl carbon here. And notice I started with 3 carbons here. I end up with 4 carbons, so I wasn't lying to you. Do add another carbon. Oh, let's do one more. Your turn. Again, what's the organic product or products for the following 3 points each? All right, anybody need more time? I guess not, so I better get to work. All right, what's the product or products for the following? Well, look for what's the ring, but that's just carbon and hydrogen. Ooh, magnesium iodide on a carbon. And what is that? A Grignard. Remember, X can be chlorine, bromine, or iodide. In this case, it's iodide. And you're reacting with CO2. Second step, acid and water. I better extend this. And now what do you get? You get a carboxylic acid that's one carbon longer than the R group you had. What's our R group? The cyclohexane ring. And that's the carboxylic acid you get. And the reason I picked this example, one time when I was talking to colleagues, I don't know how it came up, but we all agreed this is the only way we know how to make this carboxylic acid. I really can't think of this other way of making that one that's simple and economically feasible, because I know how to make this cheaply, and this is the only way I know really easily to get to that carboxylic acid. All right, let's take a 5-minute break. We'll come back and do your labs. We'll go through the lab we'll be doing today. And Dr. White's going to stretch his back because it's saying stretch me. I'll see you in 5. Actually, oh, 1 o'clock is off. Come back at 2:05. I'll give you 7 minutes. My back will thank me for that. All right. Let's get back to work, everyone. All right. Let's talk about today's lab. Today's lab is in the assignment area of D2L, and let's get it up. Today's lab is ketones and aldehydes. And let me just check. And hopefully, everybody see that on your screen? Give me a thumbs, thank you. I guess I could also ask, do a head nod, but they don't have that emoji on there. Is that how you pronounce it? But anyways, today's lab is ketones and aldehydes. And what's a ketone? Carbonyl with two R groups. This is a ketone. An aldehyde is a carbonyl, carbon double bond to oxygen with one R group and a hydrogen. And that's an aldehyde. Now, couple things. When I wrote these labs, and actually, these are the actual labs you'd be doing at ECC that I wrote years ago. And I wanted to give students hands-on experience. We're doing some simple things and also some fun things that aren't simple. First thing is solubility. Are ketones and aldehydes soluble in water? And water, I'll teach you later, is polar, but for now you don't have to know that. And you look and see if you get a homogeneous, same throughout mixture or heterogeneous 2 layers. And this one, you would be filling, if we were in the lab, test tubes about halfway with DI water. DI means deionized. We have filters at ECC that take all the ions out of the water. It's not pure, totally pure water, but it's quite good. And you add some of the aldehyde or ketone, stir it, and look and see, is it soluble or not? Well, I gave you the data, but as you see here, for this part of the lab, don't forget to draw the structures in the table, like right here, here, etc. And if you notice, benzaldehyde is solid, slightly soluble. Vanillin is soluble, and the other compounds are insoluble. And that would be part 1. Now, unfortunately, a fun part of this lab, well, not always, because students don't like smelling organic chemicals, some of them, is to give the odor. I'm omitting part 2. So we're not doing this. Just omit it. And that's why I have right here, omit. Now let's do part 3. Now, let's look at the following. As you learned today, if you have an aldehyde, you can oxidize it. Now, one oxidizing agent is potassium permanganate, which you've learned about before, KMNO4. And this is purple. And when you oxidize the aldehyde to carboxylic acid, the potassium permanganate is reduced to manganese dioxide. This is called the oxidation reduction reaction. And as I like to call it, it's a muddy brown. Think of taking mud and putting water on it. And so when you have an oxidation that actually produces a product, you'll see a color change. Now, ketones, you can oxidize. So this is a good way of determining the compound you have. Is it a ketone or aldehyde? If you see a color change, it's a aldehyde. No reaction means it will still stay purple because the potassium permanganate hasn't changed, and that tells you you have a ketone. And what I have students do is do these two, and then to make it exciting, we have an unknown, and you would do that in the lab. But since we're not going to the lab, here I give you the data. So this would be part 2. Remember, oxidation of an aldehyde, you'll see a color change to muddy brown. For a ketone, no reaction. On here, you don't have to draw the structures, but it might help to understand if I'm telling you the truth. Now, the last part, which really is sad that we're not doing it in lab, is called the cross-aldol condensation. Now, you learned about an aldol condensation where you do it with an aldehyde. Well, here, cross means you use an aldehyde, another aldehyde, or in this case, a ketone. Now, if we look at benzaldehyde, there's something very interesting. If we look at the alpha carbon of benzaldehyde, which is this carbon, it has no hydrogens, so you can't form an enolate anion. Now, this acetone has 2 alpha carbons, and it turns out when you add sodium hydroxide, and we'll do this if you were in the lab, in ethanol solvent, you get this really impressive molecule, which is called dibenzyl acetone. That's the common name, not the IUPAC name. And it's really from 2 simple molecules, you've made this very complex molecule. What's going on? Well, let's take a look. First of all, I forgot to open it up, so hang in there while I find something.